This is going to be our last lesson on circles, secant lines, and segments. On the circle on the right, notice that line AC as well as line BD are crossing the circle in 2 points at point B and D for line BD and points A and C for line AC. We call those two lines secant lines. And in general, a secant line is just a line or a segment or a ray that is going to intersect a circle at 2 points. Remember that a tangent line is just a line, a segment, a ray that intersects a circle at 1 point. So there's a little difference between a secant line and a tangent line. Given that we have AC and BD as two secant line, how can we find whatever angle 1 is? And to do that, first we're going to draw a chord AB like so, and we're going to form triangle AEB. So when we draw that orange chord, we're going to make a triangle ABE. And what we want to focus on is the inscribed angle that we make. The inscribed angle is going to be this angle in red. If you remember from the previous lesson, anytime that you have an inscribed angle, it's going to be equal to 1/2 its corresponding intersecting arc. So the measure of angle ABD is going to be 1/2 the arc of AD. If I apply the triangle exterior angle theorem, I'm going to get that the measure of angle 1, which is the angle outside of the triangle, has to equal the measure of angle ABD plus the measure of angle BAC. Those two angles are inscribed angles, so they're going to be 1/2 the measure of their inscribed arcs, as I have written right here. And simplifying that a little bit, we end up with this expression that the measure of the angle is half the sum of the measures of the two intercepted arcs. Here's another diagram showing that. So the measure of angle 1. How are you going to find out what that is? Well, first you need to know what is the measure of this arc, what is the measure of that arc. Add them together, divide by 2. Notice that the two secant lines are intersecting inside of the circle. There's going to be a similar but slightly different formula if the intersecting secant lines are outside of the circle. So for example, here I have angle 1, and angle 1 is, or the two secant lines are intersecting outside of the circle. Now notice that the equation is going to change slightly. You still need to know what this arc is, arc B. You still need to know what this arc is, arc A, but instead of adding them together, you're going to be subtracting them. So 1/2 times B minus A. Let's see an example of that. So I have a circle where the measure of arc AD is 155 and the measure of arc BC is 61. And I want to know what is the measure of angle 1. I'm going to first write out what I just told you, that the measure of angle 1 is going to be 1/2 the sum of the two arcs that are created, arc BC and arc AD. From the problem, I'm told that the measure of arc AD is 155 and the measure of arc BC is 61. So 155 plus 61 gives me 216. And then 216 times 1/2, or 216 divided by 2 gives me 108. So the measure of angle 1 is going to be 108 degrees. Here's an example of where you're going to have an angle that's now outside of the circle. And remember that when you have angles outside of the circle, you're going to be subtracting the arcs rather than adding them. So your step number one is going to be set up the problem. The measure of angle ABD is going to equal 1/2. And then notice that I'm subtracting the arcs. There's a slight problem here in that if I look at the diagram, I know what arc CD is, I know what arc AD, but I don't know what arc CA is. But luckily, I can solve for it because in order to find arc AC, all I have to do is take 360, which is the total angle sum of a circle, and then take away all the other arcs. Arc AD, arc CD. Arc AD is 151, CD is 139, 360 minus 151 minus 139 gives me that the measure of arc AC is 70. Now that I know that, I can plug it into the first equation that I wrote. AD is 151, and arc AC is going to be 70. 151 minus 70 times 1/2 gives me 40.5. So this angle over here is going to be 40.5. Lastly, what if you have two secant segments that intersect both inside of the circle and outside of the circle? Taking a look at the case where they are intersecting inside of the circle, the segment A multiplied by segment B is going to equal segment C multiplied by segment D, as I have written down here. If the segments meet up outside of the circle, if they're exterior angle, if it's an exterior angle, then what you need to do is first add up m and n, so n plus m, and then multiply it by whatever segment is on the outside. So in this case, n is on the outside, so I'm going to multiply n plus m times n. Same thing at the bottom. First, I need to find out what P plus Q is, and then I'm going to multiply it by Q, as I have written over here. So Q plus P, and then I multiply that by Q. Now, let's apply what we just saw to a problem. So I have a circle here, and I have two secant lines, NB and ND. And according to the problem, I want to know what is the length AB. What is this length here? Using the formula that we just saw, NA, which is the length outside of the circle, multiplied by NB. And notice that NB is the entire segment. That's going to equal NC, which is the outside segment, multiplied by ND, which again is the entire segment at the bottom. NA is going to be 87. NB is 87 plus whatever AB is. And that's going to equal 80, because that's what NC is, 80 feet. And then ND is 80 plus 210. Using the distributive property, which is 87 times 87, 87 times AB, and then on the right-hand side, 80 times 80, 80 times 210. You're going to get 7,569 plus 87 times AB is going to equal 23,200. Subtract 7,569 from both sides to get 87 times AB equals 15,631. And then dividing by 87, I get that AB is about 179.7. So AB is 179.7. And with that, we end our unit on circle. I know some of you have just been going crazy with seeing nothing but circles for an entire month. The next lesson is going to be on 3D shapes, 3D figures, and yeah,